Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next problem on higher order differential equation type 2. So this is our question. So if you can see here, we have cos square x. In type 2 we require cos ax plus b or sin ax plus b. So instead of cos square x we are going to write, we know that cos 2x is nothing but 2 cos square x minus 1. I take this minus 1 here, so it will become cos 2x plus 1 equal to 2 cos square x. If I take this 2 in the denominator, it will become cos 2x plus 1 upon 2. So this will be nothing but cos square x. You have to remember this, that is cos square x is nothing but cos 2x plus 1 upon 2. Instead of cos square x, I am going to write as cos 2x upon 2 plus half. I am just separating the denominator. So this equation is of the form f of d into y equal to x, where x is this part. So now the solution for this equation is given by yc plus yp. Now we will find the yc. So for yc we need an auxiliary equation. An auxiliary equation is nothing but d cube minus 4d square plus 13d equal to 0. I will take d common from all the terms. I will get d into d square minus 4d plus 13 equal to 0. So our one root is d equal to 0 and other two roots will be from this equation. But if you see this equation, this is the quadratic equation and it cannot be simplified. So the roots for quadratic equation we know we can find by using formula minus b plus minus root of b square minus 4ac upon 2a. Similarly, d will be equal to minus b. In our case b is minus 4. Plus minus root of b square, in our case b is minus 4 the whole square, minus 4, a is 1 and c is 13 upon 2a, a is 1. Okay, so this minus and this minus will become plus, so 4 plus minus root of 4 square is 16 minus 4 into 13 is 52 upon 2. If we subtract this part, we will get this term as minus 36. So we get this term as minus 36. So we cannot take the square root of negative. The square root of negative term is nothing but the imaginary. So here we get the complex root, that is 4 plus minus I, and root of 36 is 6 upon 2. So if I divide the equation, so it will be 2 plus and minus 3i. So this is our complex root. So we have the roots d equal to 0 and d equal to 2 plus minus 3i. We know that complementary equation is given by c1 e raised to m1x plus c2 e raised to m2x and so on. But for complex terms, that is for complex part, the equation is given by e raised to alpha x into c1 cos of beta x plus c2 sin of beta x, where the roots are alpha plus I beta. So our yc will be, for d equal to 0, it will be simply c1 e raised to 0x, that is m1x, plus for complex roots it will follow this equation. For in our complex root is d equal to 2 plus minus 3i. So alpha is 2 and beta is 3. So e raised to 2x into, here we have used c1, so c2 cos of beta, beta in our case is 3x plus c3 sin of beta x, that is 3x. So this is our complementary equation. After this we will find a particular integral, and particular integral is given by 1 upon fd into x, and our fd is nothing but d into d square minus 4d plus 13, and x we have calculated as cos 2x upon 2 plus half. So it will be half plus cos 2x upon 2. I'm going to multiply this term with each of the terms inside the bracket. So we will get 1 upon 2, this 2 into d, and d square minus 4d plus 13 plus cos 2x upon this 2 into this denominator. So here we do not have anything, so we can assume here as e raised to 0x. So this will be our type 1 problem and this will be our type 2 problem. So in exam, the problem will be mixture of type 1, type 2, type 3 and so on. So in this case, we used to substitute d equal to a. In our case, we are going to substitute d equal to 0. So we can substitute d equal to 0 here. So this term will become 0 and this term will become 0 and we are remain only with 13. So e raised to 0x is 1. So 2 into 13. We cannot substitute d equal to 0. When we substitute d equal to 0, this will become 1 upon 0 and it will be infinity. So for that case, keep d as it is. But if you know, I have taught you d is nothing but derivative. When it is 1 upon d, it is nothing but integration. Here we do not have any x term, an integration of simple dx, because d is dx, so this integration will be of dx. Here we do not have any term of x, we do not have any functions of x, so we assume it as 1, and simply the integration of 1 is nothing but x. So instead of 1 upon d, we can write as x. Or you can follow the formula of 1 upon d minus a the whole raised to r is nothing but x raised to r upon r factorial. In this case, it is this term where the power of d is 1, so x raised to 1 upon 1 factorial will also give you x. So simply you can remember integration of 1 upon d is x, because here we do not have any other function of x.